No, there is no template to follow later when writing the analysis. You will basically be doing your models and then save them in some format that is good for your fellow students, possibly just an image. Pen and paper will probably suffice well if you have a somewhat good camera on your phone. So there will be no template to follow. Yes, okay. I hope you have all solved this little problem. Could you guys please come up and present? No. We will continue with a little bit more of a theory now, and then we will do some, see what you got, and just find some conceptual clauses and see what you have come up with. And then I will present my solution, and you can use that and compare with what you got. And you can see a little bit of how I think about this. And of course, I'm cheating. I've been thinking about this for, well, a couple of years now, and also I'm a domain expert. Since I'm a teacher and I work at the university, you kind of like are also domain experts, or at least users, but maybe not as much as me. Screen sharing is always good to do. I think it's because Adobe seems to have changed the interface, so I don't see the full Adobe Connect when sharing. Anyway, attributes, the information, the data that is needed to support the requirements. We have already written down some attributes. For example, we had the discussion about, is price a concept or is it an attribute? And if we can settle that the price was a primitive data type, just a number, well, then maybe it's an attribute. But if it's a more complex thingy, it is probably a concept on its own. So you can look at the requirements and scan for what is actually being shown to the user, what does the user put into the system. These are probably good candidates for attributes. And we focus on primitive data types, that is like text, number, date, time, maybe. You don't really need to go into a lot of details in the analysis. You don't need to state that it's a floating point number with this kind of precision or something like that. When doing the workshop, do not add too many attributes. You can often find a lot of attributes. Oh, we have this person, he has a phone number, and he has an address, and he has a lot of attributes. And displaying these in your diagram does not really help that much. It just makes all these boxes really, really big, and you can't fit them on your paper anymore. So focus on odd, strange, or advanced attributes, some things that are not that obvious, things that are needed to understand this better. So don't just add anything there. There are other artifacts that you can use for this, for example, a glossary or a data dictionary. And if you have good tools for your modeling, this can also help a lot, because maybe you can hide away the attributes. Because focusing on the conceptual clauses and the relations between them is probably more important to understand the problem area. So we have two situations to look at a little bit more detail, and those are data type clauses and derived attributes. Actually, I changed the R there, but this did not update. Oh, should not open a new one. So, person and, well, the person has an address. However, address is probably more complex than just a bunch of text. You have the street, you have the number, and you have the postal code, and you have the area, city, country. And also these they are kind of like related to each other. You cannot just have the street kind of like needs to exist in the city for this to be a valid address. So, well, address is probably something more than just text. So we make a concept out of it. Remove it from there. So instead we add associations to show that, okay, a person lives at an address, it's his home address. And maybe he also has a shipment. So maybe you're doing some kind of like e-commerce system, and we need to ship goods to people. And they can live in one place, but want to send their goods to another place. And maybe they can also have an invoice. The address where we are supposed to send the invoice. So, okay, this does not look really that pretty. And maybe we have a supplier. And they also have addresses. They have a main office address. They have their warehouse address. Things are getting kind of like cluttered for this simple concept of stuff having addresses that is not really that complex. And things like this can really destroy your model because you won't see the important relationships anymore because everything is just connected to addresses everywhere. And in this particular case, you can use address as a data type class instead. So instead of doing that and add a lot of clutter, we do this. What else do we have? Shipment. So we use the address as a data type, but it's not a primitive data type, to avoid adding unnecessary clutter to our models. However, this is the exception to the rule that you should always use associations. And don't go overboard with this. So one problem that you could see is like this, something like this. Well, the person has an ID, and the car use this. call it PID for person ID. And what we mean is that, well, we have an owner to the car or something like that. But instead we are thinking like foreign keys in a database. And suddenly our model just consists of loose clauses that kind of like have IDs in them. And these IDs are probably software concepts because we are thinking foreign keys and primary keys in a database. So don't do this. And you are seeing how I'm using color to convey a message. So, often in design, actually, when designing software, we see the first case that, okay, we treat the phone number just, it's a string. And address, it's a string. And doing that, we get the problem of painted types. I don't know if you know what a painted type is. It's a primitive type that we add a lot of rules to. So we have it like a primitive type in the code. The phone number is a string, but then we add rules to it. Okay, this string must start with a 0, and it must have this many numbers and things like that. So we add kind of like rules to this string. In that case, it is better to do a class that is called phone number that handles this kind of stuff, because those checks and that validation often becomes everywhere in your code and becomes duplicated and stuff like that. So don't think too much about primitive data types. Often things are more complex than you think. But as I said, don't go overboard with attributes in general. Show what is interesting and what is important. Don't show all the obvious stuff. You can use other artifacts for that, like a data dictionary or something like that. Yeah, derived attributes. We have been talking about the report clauses and derived associations, and derived attributes are something quite similar. It is something that is actually calculated or can be derived from information already present. Let's do this. Have a receipt. It has a sum. We have a lot of items on this receipt, and they have a price. Well, sure, the sum is displayed on the receipt. You can see the sum at the bottom. However, this sum is just the calculation of adding all the item prices together on the receipt. So it's derived from information that is present over here. And we can show this by adding a little slash. But however, we think that the sum is so important for the receipt, so we want to show it in the model. Yes. So that's about it, about attributes, I think. Something that is quite important is history or time intervals. This is something that is often needed, but not often asked for. So it is your responsibility to ask your customers, your users, do you need to know the information for a long time? Can this information change? And should that affect other things? This makes things more complicated. So it is always a balance then that when asking your customers or users for this, you should make sure they understand that it adds complexity to the development. But also that this may be some feature that they actually want to have, because often we want to look at historical data and know what has happened. So an example on this then. Let's continue with the receipt. Let's expand the model a little bit. This is probably what you have. So a receipt can have multiple rows on it, and each row is for an item. And the item has a price, a name, and a description, and so on. If you look at the receipt, this is probably what you see. So to calculate the sum of the receipt, well, we check the rows on the receipt, and we sum them up using the item price. However, in a store, how many item prices are constant over time? Not that many. Prices go up, prices go down. You have a sale. Well, a common way to fool people to think that you are lowering the prices is to lower the price on one product and up the price on others. And then next year you take another product and you lower the price and you raise the price on the other products. So this gives us a problem, because if we are to calculate the sum of a receipt using the item price, it will change. And that is not a good thing. You don't want the sum to change. So when I buy something, the sum of the receipt is 500 crowns. But when I use the receipt the next time, the sum has changed because the item prices have changed. So it's now 750 crowns. And this is not good. So this can be solved by looking at reality and looking at a receipt. You actually print the price on the receipt, on the row. So we make a copy. When we buy, when we make the receipt, we copy the price for the item, put it on each row, and then we can calculate the sum here. That is one solution to this problem. And this is how it is done in reality. Natural. However, it is redundant. We have redundant information. And we could also have other requirements that says, well, we need to have statistics about the price of an item over time. And this does not really support that. So, another solution is to expand this into having the item. Adding the possibility for an item to have several item prices, and put some date in here. Start. End. And price. This means that our other requirements can look at an item and take a look at all the prices we have had historically for this item. And also for our receipt, it probably has a date as an attribute, and we can use this date to find out the item price. But as you see, this makes things more complex, not only in the domain model, but also later on in design. So watch out for historical data, and it is often something that is actually needed, but it's not often asked for. And it comes with a price, not just this example. Yes? Last but not least, we have generalization and specialization. Often you come across things that are more general concepts and others that are more special concepts, but are the same concept at some point. For example, we could reason about vehicles, and a more special concept that is still a vehicle is a car, a bicycle, a boat. And these things you often come about in your domain modeling. We should use the 100% rule. That is, all the information and relations for the more general concept should apply to the more special concepts. If they do not, then you probably have missed a step, or the special concept is not actually of the type of a general concept. We should be able to say a car is a vehicle. If you cannot say that, well, then you are treading on thin ice. And specialization should probably add something. You should add an attribute. You should add an association or relation, or be handled somewhat differently. Something that is kind of neat is that in reality no abstractions exist. So if you go into a store and ask to buy a fruit, what will you get? You won't get a fruit. You will get an apple or a banana or an orange. So you will always get the special concept. There is no such thing in reality as a fruit. You can't, oh, I got a fruit. What is that? You can't go and buy it. You always buy an apple or a grape or an orange or a banana. But as humans, we are so used to using these abstractions that when I say this to you, you think that I'm mad. I can go and buy a fruit. I can do it now, but no, you can't. You will get an apple or an orange or a banana or something more specific. So as software developers, we come across abstractions that needs to be specializations maybe in our system thinking, or we come across specializations that we can handle at a higher level. So maybe when scanning the requirements and talking to end users, they talk a lot about apples and bananas and pears and grapes. But we can handle all that as fruit. Or vice versa. They talk at the really, really high level of abstraction. They talk maybe about items. Well, and then they can go and buy this item and that item. But then we need to understand that, okay, maybe items are of different special types. Maybe we have fruits and we have cutlery and we have dairy and meat, and we need to sort this out. So we need to think about generalization and specialization as developers. Oops, time is running out. You are not supposed to send it in. I will just post on the course homepage my solution, and maybe we will take a look at it in the next lecture. But because time is running out for us here, I will just add one small example for the generalization specialization part. And let's take the fruit example. So we display the more general like this, and we have this arrow that actually has a direction on it. So from the more special to the more general concept. Later on, we talk about this like inheritance in both the design and in programming. So this is a concept and a notation that we will be using further on. But in your domain models, think about this. Is this concept more general? Can we use this concept on this general level? Do we need to have specializations or not? And think about the rules. Think about the 100% rule. Everything should apply. In the more special concepts that are present in the more general concept. And is a rule. You should be able to say an apple is a fruit. A banana is a fruit. Yes, I will post my solution to the scheduling and administrative problem. I also think that you could take a look at last year's lecture, so I will link that on the course homepage, because there you can see more about the reasoning behind, maybe. So any questions? Is it a good choice to first make a domain modeling and after that make database modeling? What do you recommend? Yes. As some of you maybe have noticed, domain modeling is quite similar to database modeling, and it's actually an offspring from conceptual database modeling. But you also need to be a little bit wary to not think too much about databases and optimizations and normalizations and foreign keys and stuff like that. So please forget a little bit about the database stuff, and especially these normalizations rules, and focus on the problem. Take your time to understand the problem in domain modeling. Domain modeling is not something that we do for weeks in and weeks out, but rather maybe a few hours in the beginning of each iteration. You have this time to understand the problem. And then it inspires databases and it inspires code design. Yeah, we can take the question of free software and domain models on Slack, I think, would be excellent for this. Any questions? No? Bye.